All right, good afternoon, guys. So for anyone that doesn't know, I am going to be away for the next 2 weeks. So I'm actually on a bit of a holiday out of the country. So this week of lessons are going to be pre-recorded. I think I might also have a YouTube video for you guys one day, probably on Thursday, just because I know with the holiday and then the reading week coming up, I'm expecting a lot of you to be sort of dipping out early on Thursday. So for the ones that are going to be here, I will have something for you. I'm not sure if it's going to be a video lesson like this or if it's just going to be a YouTube video, but it definitely won't be the end of the world. So just know that I am aware that a lot of you probably want to do that. So more power to you. We should all enjoy our holidays, right? So like I said, this week of lessons will be pre-recorded, and then next week is our reading week, so we don't have to worry about any sort of lessons for that. Okay. Now, I do have an assignment for you guys. It's going to be a pretty nice assignment because you're going to have 2 weeks to work on it. Okay. So that means that you'll have all of this week to work on it in class. Well, not in class, but in your spare time here. And then you also have over the reading week to do it. Okay. So I'll show you what that looks like. So this is the assignment here. It's actually all review. So as you can tell, we're getting into our fractions unit. So all of the questions on here should be things that you learned in ABE 1-2. Okay, so this is all stuff that hopefully will kind of come back to you guys. We're going to go over a lot of it, just sort of do a refresher on how to do some of these problems. The first couple pages are really simple here. It's just sort of shading in shapes to represent the fractions, right? So this one here, you want to shade in 3/4 of your shape. Okay, so you obviously would just color in 3 sections there and leave 1 blank. Okay, so it's something like that. This one, these 2 here, you have to sort of divide them into sections yourself and then do the same thing. These questions are making fractions from the shapes. Okay, so now you're given the shape and you need to write the fraction, right? A little bit of conversion here. So convert the following fractions between mixed and improper fractions. So again, that's something that we're going to do a refresher on, but hopefully you would have learned it when you did ABE 1-2 or whatever course you did before this. Okay. Some stuff with equivalent fractions, and then finally adding and subtracting fractions, both like fractions and unlike fractions. Oops. Sorry about that. Okay, so again, we're going to go over some of that. And then finally simplifying fractions. Okay, so it is a bit of a longer assignment. It's quite a few pages here. Keep in mind that the first couple pages are just, there's only 8 questions, but they take up a lot of space because of the diagrams, right? So it looks really long, but to be fair, a lot of it is just taken up by our shapes, and then you do have 2 weeks to work on it. Okay, I strongly suggest not leaving it to the very end of your reading week. Okay, I would suggest working on this throughout this week while you're, coming to class and you have extra time on campus, just because you want to do it while it's fresh in your mind. Okay, so if we do our lesson, like today we're going to do some review and you think, oh, I may as well, do the first couple pages of my assignment because it's fresh in my head. That's probably your best strategy. Just sort of get it out, get it on paper while it's still there. If you do leave it for the very end of reading week, just know that from my experience, I was a huge procrastinator when I was in school as well, so I totally get it, but it's not worth it. You're going to be stressing yourself on the last couple days of your holidays and can't remember anything that we talked about, and it's just going to be a lot easier for you guys if you try and work on it earlier, okay? So you do have the full 2 weeks. I don't necessarily recommend waiting till next week or especially till the end of next week. But whatever works for you guys, okay? I'm probably going to have a mathletics assignment for you guys as well. I haven't decided which ones yet, but they'll just be posted in the same spot as usual, right? So if you go under Content Library, Assignments, I'm going to have a section for this assignment. So this assignment will be assignment 4, okay? And it'll have the assignment date and then the due date on it. And then I'll have a mathletics section. It'll say mathletics October 7th to whatever it is, 11th or whatever Thursday is. Okay, or actually till the week after, because I'll also leave the mathletics assignment up for 2 weeks, just because I'm probably not going to be checking marks while I'm gone anyway. And again, that'll be sort of a little break for you guys if you want over the holiday, if you want to get away from your family for a bit, feel free to log into mathletics and work on your fractions. Okay. So all of that will be posted under the assignments tab. If you have any questions while I'm away, okay, so what I've been telling all my other classes is that you can email me or even send me a message on Teams, okay? I just can't promise you how quickly I'll respond. Okay, so I should have Wi-Fi for most of my trip. I just don't know how reliable it will be or how often I'll get to check my emails and my Teams messages, but I do have access to them. So if you have questions or anything like that, feel free to try and get in touch with me. I will answer you. I just don't know when, okay? But nothing should be too urgent since you don't have any assignments due while I'm gone, right? They're not due until we all get back from reading week. So they'll be due on the Monday after our break next week. So hopefully nothing will be too urgent. So yeah, that's for getting in touch with me. I guess the other thing I should mention is that since we had that test last week, okay, so we had that test on Thursday, I should have those marked. So you can find those if you go to your name, right? So go to our OneNote and then you click on your name. You have a little folder called quizzes, okay? Click on that folder. I'll have your test posted there. So it'll say like Unit 1 test. And if you click on that, it'll show you your marked test so you can see what you did right, what you did wrong, where you maybe needed a bit of practice and just things like that. So that might be one of the things that if you need to get in touch with me, if you're confused about the marking or anything like that, definitely get in touch with me and I can try and help you out. Again, nothing's too urgent though, so don't stress about it, okay? We can always fix it when I get back. Okay, so all that to say, let's get into our new unit here, okay? So we're going to be talking about fractions. The first couple days here is mostly going to be review just to make sure that we're all on the same page with things that we should have learned in 1, 2, or whatever course we took before this one, okay? So fractions allow us to split things into smaller equal-sized amounts, okay? Proper fractions, which are the first type of fractions we deal with, represent parts of a whole number or object. So with a proper fraction, your top number is always bigger than your smaller number, okay? Or it can be the same. So we have a couple of different definitions we want to talk about when we're introducing fractions. So our top number when we're looking at a fraction is our numerator, okay? So in this example here, the 2 would be our numerator. And the numerator represents the number of equal parts that we have. The bottom number is what we call the denominator. So in this example, the denominator would be 5, and that number represents the total number of equal parts that make up a whole, okay? So we'll look at a couple of examples to sort of make more sense of those definitions. But another thing I want to point out to you guys is that this line here, okay, so the line that separates our numerator and our denominator, all that line means, is divided by, okay? So this fraction, it looks like 2 over 5, okay, so 2/5, but all it really means is 2 divided by 5, okay? So we write it as a fraction because if we actually did 2 divided by 5, so if we just sort of go to the side here and we do 2 divided by 5, okay, if you type that into your calculator, you're gonna see that's not such a super nice number, right? It's actually a pretty good example. It's just 1 decimal place. But if we got into uglier fractions, like let's say we were doing something like, let's see. All right, so let's say we had a fraction like 3 over 7, okay? 3 over 7, that's the same thing as 3 divided by 7, okay? So if you do that in your calculator, you get this really long sort of ugly number, okay? We get 0.42857 okay? So if you can remember back from ABE 1-2, fractions and decimals are related, right? They both represent parts of a whole number. So this 0.428, etc. represents part of a whole number in the same way that 3 over 7 represents the same part of that whole number, okay? Fractions are just a really nice way to sort of deal with those kinds of ugly numbers. So you can see that just by writing 3 over 7, it's a lot, more friendly to look at. It's a lot easier for us to sort of deal with that as a number as opposed to that long sort of decimal that, it's easier for us to forget decimal places or maybe write the number down incorrectly. It's just easier when we deal with it in fractions, okay? So I know that fractions intimidate a lot of people. And I understand why, okay? I know that I personally even struggled with them when I first started learning them, but I want you guys to see that they're not scary, okay? They're actually a really nice method for us to deal with numbers that aren't so nice. Okay, so we have our numerator, denominator, and we know that the line between them just means divided by, okay? So like I said, with proper fractions, which is the first type that we're gonna deal with, the numerator is always smaller than or equal to the denominator. Okay, so we're always representing something that's either 1 or less. So pizza is something that we're going to see quite often when we're talking about fractions. It's just a really good visual for representing fractions, okay? So if we compare these ones here, we can make fractions out of this, right? So think about our numerator and denominator and what they mean. It's actually easier to do your denominator first, okay? So if we're looking at these pieces of pizza, first thing we can do is we can draw these lines, right? We know that we're going to have a numerator and a denominator separated by our line. The denominator represents the total number of equal parts that we have, okay? So that means all of the parts involved here, okay? So we would have 1, 2, 3, 4, 5, 6 equal parts on this pizza, okay? So based on that, 6 is going to be our denominator. If we remember our definition for numerator, numerator represents the number of equal parts, so the number of those 6 equal parts that we actually have. Okay, so in this case, it would be the number of pieces of pizza that we actually have. So if we look at our picture here, you can see we just have 1 and 2. Okay, so 2 over 6 would be the fraction that represents this picture. If we look at the next one here, so the pizza in the middle, let's start the same way. So the denominator is always the easiest to figure out because it's just the total number of sections we have. So we ignore whether there's pizza or not. We're just counting the number of sections. So this is divided into the same sort of size sections as the last pizza. So our denominator is going to be the same. It's going to be 6. Okay. The numerator represents the number of pieces of pizza that we actually have. Okay. So in this example here, we just have 1. So the fraction that represents this pizza is just going to be 1 over 6. Finally, if we look at our last pizza here, we have the same number of sections, right? So it's divided into the same number of sections as our last two pieces, our last two pizzas, sorry. Okay, so we have 1, 2, 3, 4, 5, 6. Okay, so 6 is still our denominator. When we count the number of pieces of pizza that we have, we'll find our numerator. So we have 1, 2, 3. Okay, so our numerator for this example is going to be 3, and the fraction that represents this pizza is going to be 3 over 6. Okay, now 2 of these fractions could be simplified. So just for practice sake, because this is something that we're going to go into a little bit more in depth a little bit later on in our review, 2 over 6 can be simplified. Okay, if we divide the numerator and the denominator both by the numerator, so if we divide them both by 2, okay, we get 2 divided by 2, which is just 1, and 6 divided by 2, which is 3. Okay, so that would be an equivalent fraction, right? 2/6 is the same thing as 1/3. 1/6 can't be simplified anymore. We know that because the numerator is 1. We can never have a numerator smaller than 1. Okay, in any of your fractions, you can never have a number with a decimal. Okay, so if you're ever trying to simplify a fraction, or if you're adding or subtracting and something weird happens and you end up with a decimal in your answer, you went wrong somewhere along the line, okay? Fractions never have decimals in them. Now this fraction here, 3 over 6, this is another one that can be simplified, okay? The way we're going to do that is just by dividing both the numerator and the denominator by the numerator. So, sorry, that should be a 3. So if we divide the numerator and the denominator both by 3, we'll get 3 divided by 3, which is 1. And then we have 6 divided by 3, which is 2. Okay, so that means that's 3/6 and 1/2 are equivalent fractions. Okay, they mean the same thing. Okay, let's move on to the next example. And again, apologies to you guys. I'm still sick as I'm recording these. I'm a bit sniffly today, so if I sound nasally, that's why. And I'm sorry if it's annoying to listen to. Okay, so this type of question is a little bit different. So it's asking us what fraction of these equal sized shapes have been shaded, okay? All right, so in this question, what we want to do is we have our shapes, part of them are shaded in, and what we want to do is, sorry, I just had to pause the phone there. create a fraction that represents these shapes. Okay, so if we look at our first image, again, the easiest thing for us to do is to fill in our denominator first. Okay, so the denominator just represents the total number of equal parts that we have. So if we count them all up, ignore the shading. We're not worried about that right now. We just count them all up. We have 1, 2, 3 equally sized parts. Okay, so 3 is going to be our denominator. Now, if we want to figure out our numerator, the numerator in this case is going to represent the number of shaded parts. Okay, so how many of our 3 equally sized sections are shaded in? Okay, so obviously by looking at this picture, we can see just 1. Okay, so 1 is going to be our numerator. Okay, so the fraction that represents this image is going to be 1/3. Let's look at letter B here. Okay, so we're going to solve this the same way. First thing we should figure out is our denominator. So denominator is just the total number of equally sized parts that we have. So if we count up all these sections, there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, ignoring any shading, we're just worried about how many there are in total. So there's 8 sections, so that means that our denominator is 8. Okay, now we want to know how many of them are shaded in, right? Because that's going to represent our numerator. So if we count the number that are shaded in, we have 1, 2, 3, 4, 5 sections that are shaded in. Okay, so 5 is going to become our numerator. So this fraction is going to be, this shape is going to be represented by the fraction 5/8. So with these pictures, they don't have to touch, right? So all of our shaded sections here, they're not all touching. Right, we have the one that we have marked 7 and 1 here, they're not touching, right? They're sort of separate. It doesn't matter, as long as you have the right number of sections shaded in, it's fine. It still represents the same fraction. Okay, let's look at this last one here. So letter C, again, we're making a fraction from the image. So first thing we want to do is count up the total number of equally sized parts that we have, and that will represent our denominator. So we have 1, 2, 3, 4 equally sized sections. Okay, so 4 is going to be our denominator. Our numerator is represented by how many of those sections are shaded in. Okay, so now if we want to count how many of the sections are shaded in, we have 1, 2, 3. Okay, so 3 of our equally sized sections are shaded in, so 3 becomes our numerator, and that was a really ugly 3. Let me rewrite that. 3 becomes our numerator, so the fraction that represents this situation, or represents this shape, is 3/4. Okay, let's try another set of examples here. Okay, so this one's a little bit different. It's sort of the opposite of the last question. So in this question, they're giving us the fraction, but this time we want to do the shading to match the fraction. Okay, so the first one here, we have 5/12. Okay, so they've already divided our shape into our 12 sections, right? We can confirm we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equally sized sections. Okay, so that was our denominator. The numerator is going to tell us how many of those sections we want to shade in. Okay, so we want to shade in 5 out of 12 of our sections. Okay, so if we do 1, 2, 3, 4, 5, and I didn't color them in very well, but you get the point there, okay? So again, they didn't all have to be touching. I decided to skip, do every other one. You could do them all side by side. You could do them across from each other. It doesn't matter. As long as we've shaded in 5 of the 12, we have the right answer, okay? If we look at the next one here, okay, our denominator is 8, so we should have 8 equally sized squares here. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we do have 8, so 8 is our denominator. The numerator is going to tell us, I covered the number. Numerator is going to tell us how many of our equally sized sections we want to color in. Okay, so we want to color in 8, so we're going to end up coloring in all of them, right? So if we do all 8, right, so that's 3, 4, 5, 6, 7, 8. Okay, so this fraction is represented 8 over 8. 8 over 8 just means 1. Okay, because if you type into your calculator 8 divided by 8, you'll just get an answer of 1. So we ended up shading in all of our equally sized sections. If we look at our last example here, okay, our denominator is 7, so we should have 7 squares here. So 1, 2, 3, 4, 5, 6, 7. Perfect. Numerator is going to tell us how many of those equally sized squares we want to shade in. So we want to color in 3 of them. So I'll just do the bottom 3 here. 1, 2, 3. Okay. It's really as simple as that, right? Really easy questions, matching up the fraction and then to the shape. Okay, so you do have a couple of questions like that on your assignment. So that's just good practice, but you guys shouldn't have too much trouble with that. All right, let's get into our next topic here. Okay, so we've talked about proper fractions. Now let's talk about equivalent fractions. So I mentioned this earlier when we were simplifying fractions, okay? So equivalent fractions are just fractions that are equal in value but appear to be different, okay? So equivalent fractions we can again represent with pizza, right? If we look at these 3 pizzas here, they're all divided into differently sized sections, okay? If we extend our lines here, so they didn't fill the other side in, but if we do that for them, okay, we can see that our first pizza here is divided into 8 sections, okay? So our denominator is 8, right? Our second pizza is divided into 4 equally sized sections, so that means our denominator for that one is 4. And then our last pizza is just divided into 2 big equally sized sections, okay? So that means the denominator for that one is just 2, okay? Because of the differently sized sections, our numerators are also different, right? So if we count on our leftmost pizza here, we have 1, 2, 3, 4 pieces, okay? So our fraction becomes 4 over 8. In our middle pizza here, we have 1, 2 equally sized pieces, so our fraction becomes 2 over 4. And then in our last one here, we just have that one really big piece of pizza, so our numerator is 1 and our fraction is 1/2, okay? Looking at these pizzas, it's really easy to see that they're all actually representing the same amount of pizza, right? All of them are showing us as the pizza taking up about half of our tray, right? So we can say that we have half of our pizza in all of these images. Only one of our pizzas is actually being represented by that fraction, the 1/2, right? 1 over 2 is 1/2. 2/4 and 4/8 are equivalent fractions to 1/2. Okay, we can see that in the image, right? Because we can see that the pizza is taking up the same amount of space overall, right? The amount of pizza that we have is the same. It just looks like they're different based on our fractions because we have differently sized sections, okay? So with our pizza on the left, we have those 8 smaller sized pieces, okay? So when we divide that pizza into 2, right, we end up having 4 pieces left, okay? So we still have half of our pizza left, but we're calling it 4/8 because of the way it was divided into 8 sections. It's the same thing with our middle pizza here. We still have half of the pizza left, okay? But because it's divided into fourths, right, it was divided into 4 equally sized pieces, we're saying that we have 2 out of 4 pieces left. So 2 out of 4 is the same thing as 1/2. So all 3 of our fractions here are equivalent fractions, okay? They look different, they have different numerators, different denominators, but they represent the same amount of pizza, okay? They represent the same amount of area being taken up by this pizza. So equivalent fractions are sort of an introduction to how we're going to simplify fractions, okay? So 1/2 would be the most simplified version of 4/8 and 2/4, okay? But just keep that in mind that even though they look very different, they're representing the same scenario, right? In all 3 cases, we have the same amount of pizza left. We're just representing them with different fractions because of the size of the sections that they're divided into. Okay? So that was just a really brief introduction into equivalent fractions. There's not much more to go on about those. We're going to use them a little bit more when we're doing simplifying fractions, like I just mentioned. Okay, they're going to be important when we do that. But we'll leave it at that for today, okay? So again, this is all just a review, so hopefully this is sort of jogging your memory from previous classes. Like I said, definitely try your assignment. You can probably get through the first page or 2 or maybe a couple of pages right away because it is all review and stuff that we went over today. Again, you do have those mathematics assignments and you'll have 2 weeks for all of these things, so don't stress too much about them. But that being said, don't leave them to the very end of your break. Okay, so we'll continue with our fractions review tomorrow, and yeah, we'll leave it at that.